We're live.
Yep.
So hello everyone. We did our topic on the polar sea ice loss. So I'm Alfred.
I'm Jacob.
I'm Colin.
And I'm Maya.
Just a quick recap on what sea ice is. So it's just frozen seawater. It is a thermal hailing conveyor because as ice forms, it will it will expel the salt to the ocean, making the ocean water much denser, and it'll carry oxygen, or not oxygen, sorry, carbon dioxide to the bottom of the ocean, thereby creating a carbon sink there. And the polar is the only place that can do this because the sea ices. So sea ice also has albedo, which means it will reflect sunlight. It helps prevent coastal erosions. It protects ice shelves, and it also stimulates marine life by feeding them nutrients when it melts. So the trend we are seeing here is sea ice generally forms in winter and it retreats in summer. And what is happening right now is that it's melting much faster than it's refreezing. We're going only to focus on the Arctic sea ice part because it will impact us more compared to the Antarctic ice. So, and yeah, here's a statistic for you. In the last 30 years, Arctic sea ice in September has gone down by 13.4% per decade.
So kind of based off what Alfred was saying, the sea ice is not being able to form back like it usually was in the past. So in order to look at these changes, I have a past and present set up here. So in the past, old thick sea ice made up roughly 33% of the Arctic Ocean ice pack. So this thick ice is the ice that would remain throughout a summer melt. So as Alfred was talking about, during the summers, the ice would retreat, but this thick ice is the ice that would not retreat during the summer. It would actually remain there. But now, in the present, this old thick ice makes up only less than 2% of the Arctic ocean pack. So this thick ice is still going away during these summer melts, and it's not actually staying there. Whereas in the past, lots of the sea ice would survive year-round, this thick ice. So now in the present, we're on track to lose 32,000 square miles of ice per decade. And due to this, we could see a complete disappearance of all of the ice within 15 years. So to kind of get a visualization of this ice loss, I have a summer melt shown here in the upper left. So outlined in this yellow is a median extent from 1981 to 2010 of a summer melt. So this was kind of the median average of where the ice would have melted to up to that point. And highlighted in the kind of the thermo color is the 2020 ice melt or summer melt. So this ice has retreated extremely far beyond, or like less than where it was prior, and a lot of ice has been lost, and that ice size is actually the size of 4 Maines, so it's a large area. And down here in the lower right, we kind of see a graph here, and highlighted in gray is 2020. So the summer melt, as shown, is at its record minimum. So all this ice is melting away, and as more and more is melting away and we get a more extreme minimum, less and less ice is able to stay during the summer melts, and that means all this ice will end up going away.
So a small sample of the consequences of loss of sea ice is that there's obviously rapid terrestrial habitat loss. So especially in the Arctic, when the ice melts, there's no land. So the animals that live on the ice will have no place to go. Conversely, this means huge gains for marine habitat because there'll be lots of open water. There'll be disruptions to ecosystems and food webs because animals will be all over the place, migrating or extinct. There'll be changes in global climate and weather patterns, changes in overseas transportation, and also changes in albedo and possible disruption to the thermal hailing conveyor system, which we know allows for carbon to be stored in the deep oceans at the refrigerations at the poles. And again, these images reiterate what Colin said. Now there's a lot of young ice, which does not stay over during the summers, and a lot less, let's say, thick ice or old ice, which are more likely to stay, like remain. At the bottom, it's a similar picture, just the darker colors is what it used to be in 1985, I think it says. Dark is lots of thick ice, and light is now in 2020, where there's very little thick ice. So future predictions are that our first ice-free summer will be in 10 to 20 years. The acceleration of global warming will greatly increase because there's a positive feedback loop because of albedo. So the polar ice caps are responsible for reflecting up to 80% of incoming sunlight. And when they melt, the ocean is dark colored, so they'll absorb heat. There'll also be decreased biodiversity and extinctions from habitat loss.
Okay, now let's look at the impact on this on humans. Again, there's a small sample right now because the most direct impacts of polar ice is only impacting a small people living directly next to it. So clearly there's going to be an increase in extreme weather, as you've seen, and changing temperatures will cause more tourism and changes in how people get food, as traditional methods of fishing on ice are no longer possible. The most significant and unique impact is actually through trade, because as the northern ice melts, the northern sea route opens up for longer periods of time throughout the year, and this is a much more efficient route and more boats will be able to take it. And all of this contributes to rising sea levels and changes in global ecosystems and other patterns. Then let's look at impacts of wildlife. First is direct impacts, as clearly rising temperature causes habitat loss, and it also causes severe weather, and this all impacts wildlife. But indirect changes are changes in migratory patterns, because if the poles stay warmer for longer periods of time, animals will migrate. Changes in pollutants, because we see changes in ocean currents as temperatures change, and this causes more toxins to be moved to the northern poles. But also we see more tourism and trade, and this also causes more pollutants as well. Then finally, changes to pathogen exposure. So a lot of mass extinction events have been linked with increases in temperature, as it causes more different types of pathogens to exist in certain areas. But also polar bears and other animals may stay on land for longer, and this may cause transmission of diseases between different types of species.
And so in conclusion, the key takeaways are that polar sea ice loss feeds into that positive feedback loop where once the ice melts, temperatures rises, which causes more ice to melt, and that causes more temperature rise. And polar sea ice is just one factor in global climate change. It is connected to many other factors. So for example, less Arctic sea ice or lack of Arctic sea ice means unstable water temperatures near glaciers, and that can increase and cause glaciers to melt more, and that would increase sea level. So sea ice can be indirectly influence, or can indirectly influence sea level and a bunch of other things. So sea ice is not just polar bears are losing their habitat. It's a lot of things. Thank you.